director of the community in early 2000s, and now I'm back. I was asked to hold this talk about peer-to-peer community. My name is Youjip, and it looks that I'm the least known in this community for 10 years. So before I move, I would introduce myself to you. I'm leading a center for Faulkner Systems Research at Hanyang University. It consists of 9 universities and 7 companies in Korea. And it's a research consortium for flash-based storage device and new memory systems. And it works for operating system. And also I'm an advisor for Samsung Electronics and LG Electronics, especially for making phones and optimizing their Android stacks. And my recent research focuses on Android and Ubuntu and iOS smartphones. And my work recently is on heavily towards Android iOS stack and APC and stuff. So if you are interested in getting to know more about my work, there's EastSOS at hanyang.ac.kr. My talk is about how to share video in mobile environment. So sharing multimedia contents over the video streaming of end stream. So the title of this talk is peer-to-peer streaming over smartphone devices in end screen platform. So we have iPhones and iPad and smart TVs and notebooks, and everybody has different display resolution. And I watch a video, like for example, like 12 years Spider movie, and I want to share it with my friend, or I want to watch it in my home screen as well as in my smartphone. And how can I do that effectively? That's a concern. So the techniques we propose here is how to share the multimedia contents without minimizing the server overhead and network overhead. We call it a live challenge for a sharing platform. The term we have created is the term shoot. It's something like shooting a goal with soccer. So when I watch a movie and when I want to share it with my friend, instead of sending the content directly over the network, we send a link. For doing that, we have to have a content uploaded in the server, the first issue. And then the stream I am sending and the resolution my friend has may not match. Then we have to transcode video. So that's the key part. So the term shooting is via message, and it's a way of sending the contents. So it's a commercial platform. That's the term shooting. So what we do here is when we upload a video, then our server automatically transcodes the original video content into multiple resolution from the 2 to 4 megabits per second for smart TV and Google TV, and 2 to 10 megabits per second like 1080, 720, and 480p for PC, and up to 320 kilobits per second to 1 megabit per second resolution for iPhone. So there is 1, 2, 3, 4, 5, 6, 7, and 8 different transcoding and different versions of the video exist in the server. And then it's a commercial deployment system, and it consists of video content storage and then sharing platform. And we have like 1.4 million subscribers, and there are 300,000 visitors per day. And the video storage is like 3 petabytes video storage with 1 million video files. And in our server, we encode like 2,000 video titles per day, and we have like 50 plus encoding servers. So this is kind of the system we are operating. And then this is part of the system. So when I watch a movie and I want my son or my daughter or my friends to watch the movie together with me, or I want them to watch it, then I send a link. But instead of sending direct to the video contents to him, I first check if the video I'm sending is already on the video, already in the video server. For doing that, we do some keyframes extractions, and then the video title I want to share is already in the server or not. To do that, we pre-process the video and extract like 1,000 keyframes, and then maintain a 1,000 index for a single video. So when I want to upload a video, we first check if the video has been already uploaded or not to the server. Okay, so that's the key values for match. So this server consists of content-based retrieval engine, and the interesting thing, we did analysis. Then the interesting number you have to remember is how many video titles in the world so far. How many video titles do you think that exist in the server? It's only 100,000. So in the Hollywood and Korea and India, you bring everything all together. Okay. If your server can maintain 100,000 video titles, then that should be sufficient. Okay. So it's not a whole lot. And then for 100,000 video titles, you have for each video you have to maintain like 1,000 vectors, 1,000 entries, so that you can find a match. And then we have built a content-based retrieval engine, and it turns out that the accuracy is 99.5 accuracy. So this is the entire architecture of the system, and we have context-based video search systems right here. So from now on, as a coin, let us provide some numbers we have obtained in the commercial deployed system. As I mentioned just before, we have like 1.4 million subscribers with 300,000 daily visitors, and the data is from January 2011. And we're going to look at this very interesting three issues which has not been published before. The first thing is we compare the RAM and the bandwidth and traffic volume generated by those top 3, top 5, and top 10 most popular contents. And then we also examine the server bandwidth based on the daily usage of individual users, and then the lifetime of the individual contents. So the first number is the video popularity and the respective bandwidth. So there is like 2,300 video titles in total in the server, and it's a top 3, top 5, and top 10 contents. So as you can see, there are 69. If you consider like top 3 video titles, then there is only 69 video titles. So if you look at this number, there's top 3, and top 3 video contents takes up like more than half of the entire video traffic. If you consider top 10 video titles, then that will constitute like 75% of the video traffic. So it kind of suggests that
what kind of caching and storage hierarchy you have to deploy when you're configuring your servers. So you have a bunch of hard disk drives, and you will have SSD, you will have a PCI-based SSD, and then you have RAM disk drive. So based on this traffic numbers, you will have to find how to configure your storage subsystem hierarchy in the most economical way. That's first number. The second number is the daily traffic patterns, which provides you when to perform server consolidation and load balancing and traffic caching and stuff like that. This is midnight. This is 24 hours. This is midnight, and this is midnight also. And the y-axis is bandwidth. You can see that this is a single server, and y-axis is bandwidth, the amount of traffic generated by the server. So there is a peak in the midnight, and then the lowest bandwidth around like 4 a.m. to 7 p.m., 8 a.m., and then gradually goes up and peaks at midnight. So, I mean, I think it is pretty closely, tightly related to the culture. In Korea, everybody starts watching video in the midnight. So it goes home and, take a shower and sit in front of the computer and, find the time for healing and relaxing for midnight. And then in the morning, like 4 to 7 a.m., it might be somebody might be in the subway to the work, or somebody sleeping, but it's the lowest traffic of the day. So if you want to do some managerial tasks like consolidation, recaching, migrating, then it kind of coins the time period you can do some works here. And then this trend changes in the weekend. The weekdays trends are totally different. And then this is a very, very interesting graph. This is y-axis is bandwidth of a single content. Okay, and then this is a time where the specific content is uploaded to the server. This is, I don't think you can read Korean, but this is the title. This is the title, and it was aired on 6:30 p.m. on January 8th of year 2011. Okay, it aired on 6:30, and somebody recorded it, and then digitized it, and then uploaded it to the server the same day at 10 p.m. The same day. Of course, it's uncopyrighted. And then immediately, the video traffic for the specific content just shoots up. And then the traffic goes up and quickly goes down. And then after 24 hours, it's rarely accessed. So from the contents, this is the weekly title. So it's every Sunday in the evening, it is there. So this is our 50 hours. So like after like 2 days or 3 days, it will be rarely accessed. So it kind of provides you how to and where to cache or relocate your server as it phases out. This is one of the platforms, and the other video title, which is another Sutcom, the most popular title in Korea. And the same thing. It is aired on February 22nd, 9:55, and then it was encoded and uploaded 2 hours later to the server. And then from this point, the traffic just shoots up. And then after like a day, nobody accesses it. It's the way it works. So it's kind of points the idea about how the pattern the contents is accessed. The research is not complete, it's kind of open-ended, but it kind of gives you an idea about how to configure, how to cache, how to organize your search systems. And then, there's some lessons. The content's lifetime is very, very heavily tailed. For a very short period of time, it's a sharp demand for contents, but some contents keep getting requested for a long period of time. Okay, so there are long tail demand for movie titles. But from the server, because there is peak demand for a server, the consolidation is very, very important. And the access pattern is non-stationary and heavily tailed. It has a weekly pattern in periodical fashions, and also in daily manner, it's also non-stationary. And in terms of content retrieval, the distributed content-based retrieval is very important for the scalability's sake. And when you want to share the content, you should not send the content but the link. And so we should have a mechanism to maintain the same contents in multiple QoS level, and you should be able to find the mechanism to detect the same contents under different QoS. And so also to detect the contents with different QoS levels, you have to have a very, very efficient key value retrieval mechanism for content distribution. So that's pretty much it. Thank you.